Hello, welcome back. What we look at today is be able to solve logarithmic equations. So we have two basic goals: to be able to solve equations are logarithmic equations. We'll explain that, and then be able to use logarithms to solve exponential equations. So first, let's take a look at a logarithmic equation. And so what a logarithmic equation is, it says a logarithmic equation is an equation where the variable to determine what you're trying to find is inside a logarithmic expression. So something like this. In fact, we'll solve this one here in just a moment. As you can see, we're taking the log of x, and so x is what we're trying to find. And so we need to some way kind of get rid of the log or kind of undo the log to be able to solve it. So you have a couple different cases of these kinds of logarithmic equations. The first case looks like this, where you have both sides of your equation are essentially you have logarithmic expression equals one logarithmic expression equals another logarithmic expression, both of the same base. And so what we're going to do then is use this property that we see right here, which says if you're taking the log, or basically what it says is that if this is a true statement, or this would be a true statement, if you have both logs of one logarithmic expression equaling another, and they both have the same base, what you're taking the log of both sides have to be equal. So if log base b of m equals log base b of n, then m equals n. Now, I put this, you notice, in all caps here. Always check the solutions to the logarithmic equations to make sure that you don't take logarithm or zero or a negative number. Okay, you always have to make sure of that. If you don't write down, check it, write it down, make sure you do check and be certain that's not the problem. Let's go and look at an example over here. In fact, we'll do this, start out with this exact problem. For example, so for number one, let's just do that one. So log base 2 of x is equal to log base 2 of 2x minus 1. So here we can see we have this exact situation. So we have two logarithmic expressions equal to each other. They have the same base, which is critical. That has to be true. Then what we can do then is say that this is true. Then x has to equal 2x minus 1. Now we have an ordinary equation to solve. I'll just put my x's on the left side. So if I subtract 2x on both sides, I'm actually just going to have a negative x over here is equal to 1. And then, of course, divide and multiply both sides by negative 1. And then we get x is equal to 1. Now, once again, let's check to make sure that will work. And here we're not checking so much to make sure it's correct, although that's valuable. Make sure we're not taking the log of a negative number. So log base 2 of 1 is equal to log base 2 of base. If I plug in this, it's going to be 2 times 1 minus 1. And of course, that will give us then log base 2 of 1 is equal to, first going to be 2 minus 1, which would be log base 2 of 1. So that checks, and also we're not taking log of 0 or a negative number. So that's the idea of a logarithmic equation. The first case is when you have one logarithmic expression equal to another one, both having the same base. Basically, we set what's on the insides of the logs equal to each other. Let's take a look at one more example of that. And also, we can also use sometimes our properties of logarithms to help us out. So let's say this time we have log of x, remember just log is log base 10, plus log of x minus 1 is equal to the log of 4x. Now, if you notice, this is not written that way. Okay, this doesn't look like the first one. It does not fit this example of this property so far. So what we want to do then is, can we make it look that way? And we can if we use those properties of logarithms. So this, once again, we have the same base log everywhere. We have log of x equals log of x minus 1. Since we're adding here, we have the same base, we can actually combine these, and we can make that. So if we combine them, we're going to be multiplying. So it's going to be log of x times x minus 1. Okay, so I just use a property of logarithms. And so I just added these together. Okay, so if they're adding, I multiplied them, and we can also simplify that a bit inside if we want. And so that's going to be x squared minus x is equal to log of 4x. Okay, now it is now in that form we want. Okay, log of something equals the log of something else. So now what we can do is we can say then that x squared minus x has to equal 4x. Now, hopefully you recognize this is a quadratic equation. And so the best thing to do with a quadratic equation is to get one side equals 0. So I'll make the right side equal to 0. So I'm going to subtract 4x on both sides. This will become then x squared minus 5x equals 0. Now, many ways you can solve this, including the quadratic formula, but this will factor. That's the best thing to do in this case. Factor out an x, we have x times x minus 5 is 0. And so, set each factor equal to 0, we have x is equal to 0, or x minus 5 is equal to 0. So we also have x equals 5. Now, we have two possible solutions. If we check each one, if we check x equals 5 in our original, then what we have is, go back to original expression, we'd have the log of 5 plus the log of 5 minus 1 is equal to the log of 4 times 5. Now here, we're not checking the accuracy just to make sure that this will be okay. So here, we're not, in this case, here, here, and here, we won't be taking the log of 0 or negative number, so this checks. Now, if we check 0, hopefully you can immediately see the problem. We'd have the log of 0 plus the log of 0 minus 1 is equal to the log of 4 times 0. So we'd have then, if you did this, would be the log of log of 0, which is it's outside the domain of the log function. Log of 0, we can't do that. Times the log of a negative number, also can't do that, times the log of 0. So once again, so this is, so remember, this is not, I'll say not a valid solution since you have to take the log of a negative or 0. Okay. Now it is, of course, a solution to this, but it's not a solution to the original equation. Of course, the original equation is what we care about. Okay. That's also an example where we can use the properties of logarithms to help us get in this particular form. Okay. Now, let's take a look at case number 2. So case number 2 is when you have the log of an expression or a log of something equals, and once again, it's a logarithmic equation because your x is inside the log, but is equal to something that's not a log of something, just a constant. Okay. So in that case, we can use our definition of logarithm and basically rewrite it as an exponential expression. And so we can think of this as putting both sides to the base of the logarithm to eliminate the logarithm. Okay. So let's take a look at some examples of that. And so let's look at the first one. Let's say we have log of base 2 of x is equal to 3. Okay. So we want to rewrite this or write as an exponential expression. Okay. So we do that then. If it helps, you can think of it as putting both sides. If you don't remember the exact order here where everything goes, you can always think of it as putting both sides to the base of 2. If that's the base of our logarithm. So if we think of it that way, we'd have 2, the log of 2x is equal to 2/3. Now, doing it this way, and not technically what we're doing, but at the same time, it helps to think of it this way in order to make sure we do the right thing, get everything in the right place. If you don't always remember the way the definition works, and so 2 and log base 2 cancel each other out. What we're left with then, of course, is x equals 2 cubed, which is 8. And once again, is that a valid solution? Yes. So that is a valid solution. Okay, because we plug in 8 here, we can take log base 2 of 8. 8 is positive. Okay, all right. So get one more of those. And this one we have, let's going back to log base 10 or log of x plus log of x minus 1 is equal to 1. Okay. Now here, it's also not in this form yet, but we can use those rules of exponents to put it in that form. So we want to combine these. And since we have the same base log, which we do, we're adding, so that means we're going to multiply what's on the inside. And so that's going to give us then log or log base 10 or log of x times x minus 1 is equal to 1. And also I'll just go ahead and distribute this. And so we're going to have log of x squared minus x is equal to 1. Okay. Now, in the same way, we need to write this as an exponential expression. So think of it, once again, as this put, since it's log base 10, put both sides to base 10. We do that, we have 10 to the log of x squared minus x equals 10 to the 1. Okay. Once again, of course, 10 and log base 10 log will cancel each other out. And of course, 10 to the first is 10. So what we have is another quadratic equation, x squared minus x is equal to 10. I'm just going to get one side equal to 0, so it's easiest to make the right side 0. So if I subtract 10 from both sides, I then have x squared minus x minus 10. Once again, you could use the quadratic formula, but this one will factor. So it's going to factor into x minus, it should factor. Okay, hang on just a moment. At least I'm pretty sure I meant for it to factor. Just a second. I may have to change something. Yeah, so let's make that x, sorry about that. Let's make this x minus minus 3. That should work. I apologize for that. I should have looked at that more carefully, but that's okay. We can fix that. So okay, so x minus 3x. Yeah, that will work. And so we have x minus 5 and x plus 2. So set each factor equal to 0. So we get for our solutions to this, to the quadratic equation, x equals 5 and x equals negative 2. And of course, this one is, of course, not, well, think back to our equation. Let's take a look back at our equation. That one won't be valid because if you plug that in, that would make it, you've got to take the log of negative 2, and also this would be negative. So this, although it's a solution to the quadratic equation, this one is not valid. Okay. Since it's negative, this one is valid. You can double check that. And it's possible in a logarithmic equation to have no solution at all. But in this case, it will be valid because we look back, plug 5 in here, that's valid. Take log of a positive. 5 minus 3 is still positive. So our only solution then is x equals 5 to this equation. Okay. Now let's take a look at our last case. And this is solving exponential equations using logarithms. So technically this would be an exponential equation, but we weren't, until you understood logarithms, you couldn't really solve it using this method before. Okay. So it says if you have an equation like one of these, all right, 5 equals 2 to the x plus 3 or something like this, where you notice if you've seen simpler logarithm exponential equations before, if you have the same base, you simply equate the exponents. That's not, of course, that's not the case here or here. So what we can do then, how we can figure this out, how we can solve this, is we'll actually use logarithms to help us. Let's take a look at this. Let's say, so we want to solve an exponential equation using logarithms. Now this, as long as it's exponential, we don't have to worry about taking the log of a negative number because exponential expressions are always positive. So what we're going to do then is we're going to take, we're essentially using this property we learned in reverse. If m equals n, then as long as m and n are positive, we can write then the log of any base of m equals the log any base of n, as long as they're the same base. We use that property. So let's look at number 1 and solve this. So we have 5 is equal to 2 to the x plus 3. Now, so what I'm going to do is I'm going to take, and actually I can use any log I want. I'm going to take, I'll just say any log of both sides, any base log of both sides. And I'm going to choose, in this case, I'll just choose log or log base 10. Choose one you can use with your calculator. So what I'm going to do then is be log of 5 is equal to the log of 2 to the x plus 3. Once again, this is using this property right here. If these two things, positive things, are equal, then I can take any log of both. Okay. Now, what does that do for me? A couple of things to notice. Make sure it's clear. This log of 5 is just a constant. That's not a variable. It's just a number. Now, I can also use my properties of logarithms to bring this expression down front. Now I have log of 5 is equal to x plus 3 times log of 2. Okay, now, so I got the exponent or the variable out of the exponent. I'm going to distribute the log base 2 to both sides. And so I have log base 5 is equal to x times log base or log of 2 plus 3 times the log of 2, distributing the log of 2. Now, still to get the x by itself, so I'm subtract this once again. This is also just a constant. Subtract this on both sides. So I have log of 5 minus 3 times the log of 2 is equal to x times the log of 2. Then lastly, divide both sides by log of 2. The log of 2 is also just a constant. Divide both sides by that, and I have x is equal to log of 5 minus 3 log of 2 divided by log of 2. Now, you can put that into a calculator or a website like Desmos and get an approximation for that, but this is the exact answer. Okay, also I will say, you can try this on your own and verify if you use the natural log instead. This equation, the solution have the same form, just be natural logs. So it would be ln of 5 minus 3 times ln of 2 over the ln of 2. You can also try that and see that even though the individual logs are not the same, identical, this fraction, this whole thing is equal to this whole thing. So we can use any base log we want, and we'll get the same result. Okay, so what we've seen so far today are how to solve logarithmic equations. So remember, logarithmic equations where the variable is inside the logarithm. We saw the two cases of those. Then we saw how to solve an exponential equation using logarithms. Thank you. Have a good day.